has changed over past 5 to 10 years owing to data and data-driven work. Traditionally, if you're talking about any business analyst, the work has been gathering requirements from business, translating them into system design, engage with technical team, and be the bridge between business and technical team. It means their job has been to understand the business, and once they have understood it, develop a document which could be used by a software or technical team to come up with the technical solution. In terms of skill set, when we're talking about understanding business, understanding of software development lifecycle, namely agile or SDLC waterfall, and estimate the project. And when it comes to tool, we are talking about mainly 3 tools. One being Microsoft Excel, second being Microsoft Excel, and third also being Microsoft Excel. It means you are able to do pretty much all of your job using Microsoft Excel. You never had to go out of that shell in order to solve any problem, because your all requirement was able to fit. Like, take an example, how many hours a developer will work, how many times it will take. So these kind of number data was enough to be handled by Microsoft Excel. But if I talk about recent BA jobs in the current Toronto market, what I see here, this one talks about loves data, heavy hitter on the analytics side. So they are demanding analytics skill. Second one, they're talking about knowing of SAS on top of SQL. So difference between SAS and SQL being, in SQL you can run basic queries or you can run advanced queries as well. But these queries are not in a nature of statistical data, statistical modeling. SAS is more on that. You have to, so it means they want to have some exploratory statistical analysis. You do something, you get the mean, mode, median. You want to see the distribution of the data. And also you want to see how many standard deviation away from this data. So basically they are expecting you to understand the data. This one, it talks about bonus being a statistical programming, SAS, R, and Python. The difference between SAS, R, and Python is like that. They pretty much everything you can achieve the objective, but SAS usually in a big, large enterprises because it has a licensed software, and R and Python pretty much you can use anywhere. Again, data analytics job, they are looking for data analytics in Python and R. So if anybody is a new grad who is actually maybe just going to school, they may be very happy to take a maybe 1 or 2 credit on mathematics or statistics. But the problem with anybody veteran who has been doing this for 10, 15, 20 years, it is not possible for them to go back to school. In that situation, they may be looking to upgrade their skill in Python. So now, new tools what we talk about, of course, Excel, Python, or R. But when we talk about Python and R, people get carried away. They start looking for millions of courses, this and that. See, Python is a very general purpose programming language. You possibly cannot learn everything. So again, you don't have to learn everything for this job. In this job, you only need to focus enough Python to do your job. So I would say if you're looking for some kind of solution, you look for Python for analytics. That's it. That will teach you basic Python and more heavy on the analytics side. How you can do basic day-to-day analytics. How once you graduate from Excel sheet, how you go to the next level. So the next thing you should be looking for is the Python for analytics, R for analytics. These kind of solution you're looking for. You don't want to be a Superman or you don't have to be a Rockstar Python developer. Just enough Python to do your job. So this is for this webinar, and we'll have demo subsequent session.
Hello all. So here we are. Our focus today is to learn Python for business analysis. And in today's webinar, we are going to concentrate on Python for the sake of simplicity. Needless to say, same thing we can do for R. Maybe we will cover it in some other sessions. Today, we are going to focus on Python. So let's just jump into the real thing. Let's start playing with the data right away. here we are. So this is how we are using an IDE for Python. Basically, Python is a huge platform. As Chandan has already talked about, Python can be used as a web development tool, as an automation platform for machine learning, for artificial intelligence, and so on and so forth. But in this plethora of applications, how to make Python relevant for business analysts is what we are going to do today, right? So the first thing is to just get some basics right. So as you know, Python is an extensive platform, and the most important feature of Python is that it is supported by innumerable number of libraries or packages which make uh, given things very easy and very streamlined. These are called libraries, and the first thing to use these libraries is to import it in your existing session. So here, for example, what the first thing that we will be doing is import some of the important packages which we are going to use in today's session. NumPy is basically numerical Python. So anything that we want to do numerically, basically some kind of numerical operations like calculations of percentile, adding some arrays and things like that, we do using NumPy's library. Pandas is another library which enables us to handle a relational data set like spreadsheet data or a CSV file or a file from let's say Oracle you have downloaded to your machine, and it's large file but it has the rows of data and so many columns. So those kind of data sets can be handled very easily using pandas. Import CSV is just a way of invoking the function so that we can import a CSV file using pandas. OS is nothing but it's kind of we are setting, we use it to set up the home library so that we can tell Python the exact location of the folder where we have kept our data sets and where we want to write back the outputs so that we don't have to give the whole path again and again. It just makes the working on Python very easy. Matplotlib is a library which is used for the development of two-dimensional plots, graphs, charts, and so on and so forth. It's very, very convenient and very, very simple, right? So let's import these packages or these libraries. The way to do is you simply select it and press Control Enter. That's it. It is imported. Next thing is to set up the home library. For example, in my local machine, I have saved all the data sets in the folder d/training/webinars, right? So all that I'm doing is I'm telling Python where is my data located. That's all. Now let's jump into using a data set practically. To use a data set, let's say that data set is in a CSV file format. We need first to import this data set into Python so that we can see it and we can work with it. The syntax for bringing in that data into Python is very, very simple. What we need to do is I'm just giving the file that I'm going to read and use as a Python file, Python data frame. We are going to call it sales data. We are going to use pandas.read_CSV function just to read. This tells Python that you are going to read a CSV file and you want to read it in the context of pandas library so that it invokes that library and it applies all the features and functions available in pandas. And then we simply tell the name of the file that we want to read. This is the file that you have actually saved in your location here, right? So let's just read it. Okay, now if you can see, we have imported the data. We can see it here. We can see that there is a column called retailer country. There is a column called order method type, and so on and so forth. There are numerical columns called revenue, quality, and gross margin. There is something called index, which is nothing but kind of a row number, which Python automatically attaches to every row. Now we have read the file. What next? Let's analyze some of the basic features or some of the descriptive analysis of the raw data so that we can make a basic sense of the data. So what we want to do is we want to see, okay, what is the variability in my data? What is the maximum? What is the minimum? And what is the average, and so on and so forth. So the way to do is we have imported this data called sales data. I want to describe it and I want to transpose it so that I can see it better visually, right? If I do that, we have a new file called T. Let's open it. As you can see, we have a variable called revenue. So in our file, there are 88,475 records which are populated, which has revenue. The average revenue is 42,638. The maximum is some 1.63 million. The median or the midpoint of the data is 21K. The minimum is 0. So you can see that there is a huge variability in the data. There are customers who bring nothing as far as revenue is concerned, and there are customers who bring like 1.6 million. That's reflected in the standard deviation, which is very high, 65,784, right? But if you see at the quantity, the second variable, quantity of the items that the company has sold, you can see that average quantity is 780 per customer. The median is 333, right? So basically the median tells me that 50% of the customers are sold the quantity, the item quantities of 333 or more, as well as 50% of the customers actually buy less than 333 items. Similarly, gross margin, you can see that the average margin is 44.9% and the median margin is 45%. So it means we practically we make the same profit from every sale, right? But it also shows a lot of variability because we have 77% profit margin as well, whereas at some places we end up actually selling it at a loss with a 12% loss, right? So that's the very innate and very easy and very intuitive way of looking at the data and looking at the insights that a business analyst really needs, right? So ultimately we have to know that business analysis is not about crunching the data. It's all about coming up with insights, right? Now we have covered the numerical variables. Now let's say I want to see, okay, I have so many countries where my items are being sold. So how many countries are actually there and how much do I sell? So for that, let's do some descriptive analysis of the categorical variables. So here I tell Python that I want to look at sales data and the variable is retailer country, and I want to look at the total value counts. How many entries are there? I can see, okay, I can print it to the driver or to the screen, but maybe there needs to be done, something needs to be done to make it look better. Maybe I can write it as a new file so that I can open it and I can see it. As you can see, this is a far better way of looking at the data. And Python also allows you to simply sort it at a click of a button. So I can see that in the United States, I have 7,482 sales, but in Denmark, I have only 2,358 sales. For a business analyst, this should be the starting point for any analysis. Basically, if you know that on an average in UK, for example, you sell 6,000 units at this point of the year, right? Now, last month, you have been able to sell only 5,102 units. That's a huge aberration. And that means that the business analyst has found out a problem or a reason to delve more into some business issue that is impacting the business, right? So this is a very basic way of looking at the data and identifying some problem areas. Maybe the next thing will be, okay, I have got these numbers, but I need to send it to other product managers and other people who are working with me. They don't know Python. I need to send them a CSV file. How do I send them? Okay, so I made this file T. Now I just need to write it as a CSV file. So I use to_CSV. and I give it the name country underscore counts. Okay, these are the counts of the sales which are happening in each of these countries, and I can simply run it, and this file country underscore counts.csv will get written to the home library that we just created before. Right now you can attach it to a mail and send it to anybody. That's your BA job, day-to-day functioning. Right, since you are a BA, you are supposed to delve more into the data and find out the pain points. How do we do that? So let's look at the revenue. Okay, I have seen the average revenue, I have seen the median revenue, the maximum and minimum, but I want to know how my revenue is actually distributed, right? So let's calculate the percentile distribution. What percentile does is it gives you the cutoffs above which a certain percentage of customers in this case are concentrated, right? So if we run this, we can see a very simple way of looking at data statistically. So here it tells me that out of all my sales, 5% of my customers, top 5% of my customers give me revenues of 152K or above. Only 1% of my customers give me revenues of 312K or above. But there are 10% of the customers that I have that actually give me less than $3,262, which is like a huge challenge for a business, right? So most of the business opportunity will lie in moving these customers to any bucket which is on the higher side. So I will do a lot of benefit to the company if I could make 50% of these customers from percentile 20 bucket to percentile 30 bucket, and so on and so forth. That's another angle, or that's another view of looking at the data. And it's so simple using percentile in Python. Have we been doing it in Excel? It will really involve a lot of calculation and dragging down the columns, which invariably Excel kind of hangs, and you never know where there is an opportunity for making a mistake which you might not even catch. Right, now let's calculate something new. A lot of times we need to calculate a new thing. We need to develop some ratios, design some new variables which can provide a new way of looking at something, or a new variable which actually syncs with downward people who are actually looking at those KPIs. So let's calculate a new KPI. Let's say that new KPI is net profit. What is the actual profit that I'm making? Okay, how do we calculate it? We want to mix revenue and gross margin. We want to multiply the revenue with gross margin, and just at a click of a button and one line of code, I can calculate it. And if I open it, sales data, I can see without much ado, I can have a new column called net profit, which has all the total revenues, basically the net profit that we have made from that sale. And again, we can simply sort it. We can see, oh, these many sales have been made actually at a loss. So as a BA, your job will be to find out why did we sell this at a loss. And these are the sales where we actually made a lot of profit, a lot of money, right? So it simply tells you where to focus on, and very easily. Now, we want to filter out some data. I want to find out all those sales where we have made net profit more than 100K. Very simple. I simply tell it, okay, look into the sales data, look into the variable net profit, and calculate all the rows, return me all the rows where the net profit is more than 100K. That's it. As I can see, I have got 1600 such sales, right? Pretty simple. Now, I want to group by some data so that, I can visualize it better, and I can know in combination, let's say the retailer type and retailer country. So in which country, what is the retailer type which is giving me higher revenue on an average? So if I simply look into the first example, what we are doing is we are aggregating retailer country and retailer type over revenue. So let's see what it gives me. It tells me that in Australia, if I look at retailer type, if you see clearly, among all these retailer types, on an average, we make most amount of money on the golf shop, right? And so on and so forth. Similarly, example 2, we can see by product line. Example 3, we can look at product line and the overall revenue. So if you look at here, we can see the product line versus revenue. It can clearly tell me that on an average, I do not make a lot of money on outdoor protection, right? So it tells me what to look. Now, we have done all this analysis. Let's do some visual presentation thing, right? Let's see if we can look at our data figuratively. So we do some basic hygiene setup, and then let's look at bar diagram of product line versus revenues. And I can clearly see that it's the golf equipment which sells the most. And it is a very simple way of showing up the data, and it's a very simple way of actually creating something. Let me create a pie chart. One line of code, and you can have a beautiful pie chart which tells you how the sales across all these countries are distributed. A line chart where I'm simply plotting a product line with revenues. And as I can see, it shows the same thing, that golf equipment is the most, outdoor protection is the least, and somewhere in the middle, you have all the other 3 categories. So you see, we did nothing fancy here, but we did everything that a normal BA will be doing every day, innumerable number of times in their daily lives, by wasting tons of hours in a platform like Excel. Compared to that, something like Python makes your efficiency increase manifold, and that's the utilization of Python. Thank you.
It was a great demo by Shailendra, and I would like to quickly highlight that we do provide such type of course like Python for analytics and R for analytics. And when it comes to analytics, these 2 languages stand out compared to any other. Primary reason being easy learning curve and inbuilt libraries for your analytics tools. And also you don't have to worry about memory management or any kind of syntax highlightation. So our Python for analytics course is a ground up approach. We don't really work on getting quickly done it, rather than we focus on teaching the fundamentals. So introduction is covered in the course. You don't have to know Python before. And after doing a little bit of introduction like data structure and all, we start getting into the really working use cases which are used in a day-to-day use cases, real analytics problem, and using that. And it includes analytics, data handling, visualization, and advanced data mining. And during the course, we try to use as much as possible open source available data. And also after the training, we give out a project to do it once anybody's done the project, and we issue the certification for completion. Similar course is available for R, and R is again a very versatile language, and that pretty much the syllabus is similar to whatever we do on Python, we can achieve same thing on R. Now it comes to the individual, what is their background, what they want to do. And also if you want to see what is difference between why you choose R or Python, there is a blog post in the description below is mentioned. You can check it out, and based on that you can do judgment. In a quick short, if you're looking for a more of a software development background, or you're looking to do on a really big data set of thing, and you are comfortable and you think you're going to use PySpark, then Python is a good solution. If you're going to do more of a descriptive statistical analysis, or not necessarily doing on a big data, although Spark R has the feature, but in that case R is your solution. So this is for this webinar. We'll see you on the next webinar. And I would like to thank everybody who joined the webinar, and please subscribe to the channel, leave the comment below, and see you on the next time.